Hi everybody, I'm Sophia, one of the members of Seattle INTEGIRLS, and today I'm going to be going over our Seattle INTEGIRLS Spring 2026 competition, Elementary Division, all these solutions. So I'm very excited, so let's just get into it. I'm going to group these into questions of 3. These are all taken straight off of our Google form that we sent out when we did the online competition this year. But yeah, let's just get into it. So I'm going to start with question 1, which is round this number to the nearest 100. I'm going to make this bigger. So what we're actually dealing with here is we're dealing with the number 6767. But we're running to the nearest 100, and let's remember, this is the ones place, this is the tens place, and this is the hundreds place. So we're really narrowing our focus here on the 7. And in order to do so, we look at the following number, which is the 6. Since 6 is greater than 5, we want to raise this number, the 7, up, because 6 is greater than 5, and the next number following 7 is 8. So our final answer in this case is going to be 6,800. And this makes sense because 6,767 is closer to 6,800 than it is 6,700. Amazing. Now we're going to go on to the next one, which is, what is the remainder when 424 is divided by 7? Well, let's just start. So I'm going to do a little bit of division here. And what is 424 divided by 7? Let's just start here. What is 42 divided by 7? Well, that's pretty easy. That's 7 times 6. And this is going to get me something like 420 here. And I have a remainder of 4 if I multiply it by 0. So I know that 7 times 60 is 420. So I have a remainder of 4, and this is actually going to be our final answer. So this is a really quick solution if you are pretty familiar and comfortable with long division. This was the skill we were pretty much testing here. Pretty advanced. But yeah, we have a final answer of 4. And we wanted to make it a little simpler, so you don't, it's not required to use long division here. If you do know your times tables and you know that 6 times 7 is 42, and then times 10 again would be 420, just add a 0 and then subtract there. But yeah, long division is very helpful in this scenario. Long division is also very helpful in our next question, which is how many quarters are equal in value to $39.25? So hopefully everybody here knows that a quarter is 25 cents. If not, I recommend you learn that. And so that means that there are 4 quarters to $1. Hopefully we also know that too. It's okay if we don't though. So if we know this, I'm going to scroll. We know that 4 quarters equals $1. And we know that there's $39, then we can do 39 times 4. And I'm going to go really slow here because I know this can be tricky. 9 times 4 is 36 from our times tables. We carry that 3. What's 3 times 4? That's 12. 12 plus 3 is 15. So here we go. This is the number of quarters in our dollars, in our $39. But we have that extra 25 cents, don't we? So I add an extra quarter to get a final answer of 157. Amazing. So yeah, this required some common knowledge of how cents and quarters work, but hopefully that was pretty straightforward. Moving on. What is 30%? Oh, we actually have a typo here. Awkward. What is 30% of 1100? One amazing tip I would like to reiterate is 30%. When we think of percentages, we should think of over 100, percent per 100. So I can rewrite this percentage as a fraction. In fact, this is actually 30 over 100. Now, when I'm asking for a percentage of something, I'm just asking what's 30 over 100 times 1100. Now, the amazing thing here is we can actually cancel this, and this turns into 11 because we're canceling the zeros. So our final answer is just something like 11 times 30. Which I will do very slowly. 11 times 30. This is going to be something like 0, 0. Then I go 3, 3, 3. I add this up. This is going to look like 330 as our final answer. Perfect. The next one's a little simpler. Grace has 23 cookies. Angela has 21. How many cookies do they have all together? Well, this is going to be some addition here. We have 23 plus 21. And actually, if you notice this, question 5 has been a lot easier than the previous question. So this is why you shouldn't give up. There's always going to be a question you can solve somewhere along the way if you don't give up. So yeah, continuing this, 23 plus 21. Let's go units digit 4. Tens place 4. Final answer 44. They have 44 cookies in total. Next, oh my god, it's me, Sophia. Sophia's teacher told her to divide a number by 3. She messed up, whoops, and instead multiply the number by 3 to get 27. What was the number Sophia should have gotten if she'd listened to her teacher? Hopefully I get this right because this is me. I have been featured. But in my mistake, what I did was I multiplied something by 3 to get 27. So if I want to reverse this, I want to divide 27. So 27 divided by 3. With our times tables, we know this is 9. So we know that this was my original number. But my teacher told me to divide this number by 3. So what's 9 divided by 3? 9 divided by 3 is 3. So the answer I should have gotten is actually 3 had I listened to the instructions. So keep in mind, listening to the instructions is very important. Okay, moving on, making some good progress here. What is the probability that I draw a red queen in a standard deck of 52 cards? Some information here is that the 2 suits, diamonds and hearts, are red. So very important information here. We have in a standard deck, my ounce of common knowledge for you guys here is we have the clubs. I actually don't know if this ink, oh, and the question is actually not showing up, so that's embarrassing. Clubs is black. Spades is black. Now what is red then? Red is hearts and diamonds. Okay, great. I want to draw a red queen. More common knowledge, or this isn't common, I would say, more knowledge. There is 1 queen per every suit. So if there is a queen in my red suit, my red hearts, and my red diamonds, then I'm going to have 2 queens. So there's only 2 cards I can draw out of the 52. So that probability is just going to be 2 over 52. If I wanted to simplify that, however, I could divide each top bottom by 2 to get 1 over 26. I'm sure we would have accepted either answer, but it's always good practice to simplify. And then moving on to Maya's Bakery. Maya's Bakery consists of 5 different types of cookies, 6 different scoops of ice cream, and 3 different flavors of icing. Assuming Maya's specialty is 1 cookie topped with 1 scoop of ice cream and 1 flavor of icing, how many different specialty cookies can Maya make? Well, we know that we have 5 different types of cookies. We have 6 scoops, and we have 3 icings. Now, because each of these are separate from each other, one thing I can do is I can multiply these together. And why does that make sense? That makes sense because first I have 5 options, but then I have another 6 options separately that are, as I would like to say, independent. And then the last option I have 3, and they're all not in correspondence to each other. They're not related to each other. So that's why I can multiply these. So our question essentially is, with all these words, we're just asking you, what is 5 times 6 times 3? Starting off small, we know that this is 30, and then 30 times 3 is 90. So our final answer that we're looking for here is 90. Awesome. And then question 9. A rectangle has side lengths 6 and 8. What is the length of the diagonal in cm? This is actually very tricky if you do not know the Pythagorean theorem or you don't know the Pythagorean triplets, which is okay because I'm going to explain it right now. Rectangle, length 6, 8, and we want the diagonal. Rectangles obviously have 90 degrees, and the Pythagorean theorem here, a really amazing thing, is saying that if I have a right triangle with side lengths A and B, then the diagonal, or the hypotenuse, C, can be determined because A squared plus B squared equals C squared. For those that do not know, squaring something just means multiplying it by itself. So, following this, this must mean 6 squared plus 8 squared equals my diagonal, which I'll call a question mark squared. What is 6 times 6? 6 times 6 actually is just 36. What is 8 times 8? 8 times 8 is actually 64. If we add this together, this is 100. And my pen is glitching. Okay, hold on. I can't draw circles. What is going on, guys? 100. And this is AKA the question mark squared. So what number squared or multiplied by itself is 100? Well, with a little bit of computation, we can figure out that this diagonal is actually equal to 10. And that's our final answer. So the diagonal length is 10 because of this beautiful thing that we call the Pythagorean theorem. Next set of questions. If x equals to 1, what is the value of 5x squared plus 3x minus 4? More computation. How fun. Again, as I've explained, this squared means we're multiplying it by itself. So if x equals 1, 1 times 1 is 1. So then we have 5 times 1 plus 3 times 1 minus 4. Now 5 times 1 is 5 plus 3 minus 4, which is equal to 8 minus 4, which is just 4. So our final answer here is 4. So, very computational. Next question, again, more computation. Wow. We want the sum 1/3 plus 1/4. And how to add fractions? Well, we want a common denominator. And let's say our common denominator is 12. So 1/3 is actually equal to 4 over 12. And that is because I can divide 4 by top and bottom to get 1 over 3. And similarly, 1/4 is equal to 3 over 12. Now I can finally add these fractions up because they have the same denominator. And what's 4 plus 3? Well, I think that is 7. So the final answer is 7 over 12 because denominator, common denominator is the same. Amazing. And finally, we have Emma and Ella having a very insightful conversation. They each choose a different integer. Please let us know this. Different integer, this means that all the numbers are different from 1 through 8 inclusive. Ella says, my number is divisible by 4. And Emma responds, well, now I know your number. Ella replies, I know yours now too. And now we're going to assume that Ella and Emma are working with perfect logic. So the trick here is that if Ella's number is divisible by 4, the only way that Emma would know her number is if Emma's number was also divisible by 4, because we know that their numbers must be different. So it actually doesn't matter which divisible by 4 integer Emma or Ella chooses, but let's just assume Ella chooses 4. If Ella chooses 4 and Emma chooses 8, this is perfect. Because once Ella says my number is divisible by 4, Emma knows the only numbers divisible by 4 between 1 and 8 are 4 and 8, and Emma has 8. So Ella must have chosen 4. And that logic is reversible, which is why Ella says, I know yours now too. The same thing works if Ella had chosen 8 and Emma had chosen 4, but if we add these up, this gets us 4 plus 8 equals 12. So that's our final answer. It is 12. Fun fact, this is question 12, and the answer is 12. So, coincidence. And our final set of 3 questions is, if you pick a number 1 through 15 inclusive, what's the probability you picked a prime number? Definition of a prime number is a number that is only divisible by 1 in itself. So let us list the prime numbers here. The prime numbers I claim are 2, 3, 5, 7, 11, and 13. Oh, did not realize you guys can't see this. This is pretty self-explanatory. 2 is only divisible by 1 and 2. 5 is only divisible by 1 and 5. For example, 8 is divisible by 1, 2, and 4, which is why it's not a prime number. But how many of these numbers do we have? I think we have 1, 2, 3, 4, 5, 6. So we have 6 of these numbers, and in total, we have 15 numbers. So 6 over 15, simplify it, divide each top and bottom by 3 is 2 over 5. So our final answer is 2 over 5. This is our probability. Amazing. Now moving on to our next problem. If an isosceles triangle has 2 angles of 20 and 140 degrees, how many degrees is the third angle? Well, fun fact of the day is a triangle, the interior angles, they sum to 180. So, if I already know that one of them is 20 and one of them is 140, and this question mark here, I can divide, or I can subtract, both sides by 20. So I get something like 160 equals 140 plus question mark. And I do the same thing. I subtract both sides by 140. So I get question mark equals 20. And yay, this follows our requirement of an isosceles triangle. If you don't know what an isosceles triangle is, it has two angles that are the same. So 20 and 20 makes sense. And that's our final answer, 20 degrees. And now we have come to the long-awaited question 15. I'm very, very proud. Sienna is running on a track. She wants to run a mile, which is 4 laps around the track. Since she is tired, each lap takes 3 times as long to run as the previous. If Sienna's second lap took 3 minutes to finish, how long in minutes did it take for her to run all 4 laps? Well, we know her second lap took her 3 minutes to finish. So I'm going to say 1, 2, 3, 4. We know her second lap took her 3 minutes to finish, and we know that each lap takes 3 times as long to run as the previous. So if the second one took her 3 minutes, that must mean the first one only took her 1 minute, because 1 times 3 is 3. Now I just follow this pattern. I just keep on multiplying by 3. So what's 3 times 3? That's 9. 9 times 3 is 27 minutes. And now I'm just going to add all of these guys up. So what is 1 plus 3 plus 9 plus 27? That, in fact, is 1 plus 3, which is 4. 9 plus 27, which is 36. And then finally, 4 plus 36 equals 40. So our final answer, amazingly enough, is it takes Sihon 40 minutes to run all 4 laps. And that concludes our very last problem of our Seattle Integrals Spring 2026 Elementary Division. Hopefully all of these made sense. Feel free to leave any questions if not. But yeah, hopefully these answers were helpful in some way, and we will be releasing other divisions very soon, so keep an eye on that. And other than that, thank you for watching.